All right, we're going to be doing number 33 here. It's an interesting looking problem. Rewrite each geometry formula using function notation. Evaluate each function when r equals 5, then explain the meaning of the result. So that's just a lot of steps, but it isn't hard. So we have part A. We're looking at the diameter, and the function is d equals 2r, but we need to write it in function notation. Quite easy. The diameter given the radius is equal to 2 times the radius. This is essentially function notation. What is this? How did I just do this quite easily? Well, you have to look at the inputs, which is r, and the function is the diameter, so it's d. And then d of r means the diameter given the radius is equal to this. So you know that the function is going to be producing the diameter given the radius, which is quite easy to r. You can even write this one function by yourself. And all of these you can. If you took basic geometry or you know basic geometry. Next we have produce when r, so evaluate the function when r equals 5. D of 5 equals 2 times 5, which is 10. This is the next step. And then explain the meaning. The meaning is when the radius is 5 units is 5. Let me write this neater. Okay, so it's 5 units. The diameter is 10 units. This is the meaning. All right, let's see part B. So part B says that the area is A equals pi r squared. Again, this is an area that has an input of the radius. So essentially, the area is being outputted when there's a certain input of the radius. So the area is going to be outputted based on the input of the radius. Okay, so the radius is determining of the area. This could have been rewritten for the diameter as well if you wanted to. You would have a different formula, but it would be A of D, right? Based on the diameter, you're getting the area. So essentially, that's what it is. You can, if someone was to say, was asking you to, analyze what it means, then basically what you would say is, based on the radius input, we are getting an area output. And this is typically how you write the area of a circle formula, because radius is extremely important. Right, so that's that. And then when r is 5, the area is pi 25 pi. I'm not going to write this as a decimal, it's just 25 pi. So when the radius is 5 units, the area of the circle, or a circle really, I'm just going to say of the circle, is 25 pi. Because any circle you take, right, any arbitrary circle, and you make it a radius 5, the area is always going to be 25 pi, because the area of a circle is always pi r squared, no matter what, right? It's pi r squared. So 5, any circle that has a radius of 5 will always have an area of 25 pi. So it's quite simple. Let's look at part C. So circumference, and these are all in terms of area. I just realized that circumference is C equals 2 pi r. So C of r equals 2 pi r. Same thing here. Input of radius, output of circumference. So circumference is written in terms of the radius, which it typically is. And then if we have C of 5, this is equal to 2 pi 5, or 10 pi. Not 5, not 2, 5. This is 10 pi. What does this mean? When the radius of the circle, of a circle really, but of the circle, for this circle right here, it's a changeable circle, it's an expandable circle, maybe it's a computer graphic or something like that. When the radius of the circle is 5 units long, or 5 units, the circumference is 10 pi units. That's it. And I should specify here as well. Here's units. Units. And again, here we could have also said, yeah, 5 units, 10 units, units. Yep, okay, good. Good. And this would be your answer. That's it. This one was just mathematical connections to geometry. Hope you found this video helpful.